Okay, so section 5.2 is called right triangle trigonometry. Right triangle trigonometry. All right. And really, I guess I should start off with like a formal definition of what a triangle is, but I think we kind of know what a triangle is, right? Definition. Well, we know what a triangle is. So I'm not going to bother with that, right? It's a three-sided polygon. What's a polygon? That's actually a great question. Polygon, it doesn't really have a nice definition. Yeah, if you try to formally define what a polygon is. But basically, if you put a bunch of points in space and you connect them so that they form a closed loop in such a way that you don't intersect any two edges, that's a polygon. Okay. So now that we have that, right? We know what a triangle is. We haven't defined a right triangle yet, so I'll do that, right? A right triangle is a triangle with a right angle in it. A 90-degree angle, right? Fair enough. Yeah. And so, you might realize this already, but like a right triangle actually only has one right angle in it. Yeah, it's actually impossible to have two right angles in it. And so let's talk about that for a second, right? Just some facts from geometry that, maybe have never been proven, but these are easy ones. There are some that are pretty difficult, so I won't go through those. But the first fact we're going to go through here is that the sum of the interior angles of a triangle, any triangle, not just a right triangle, is always 180 degrees. 180 degrees. Yeah. And so I'm just going to kind of give a picture by proof here. All right. So the picture by proof goes like this. Let's draw a triangle where the base is horizontal, let's say. And maybe it looks a little bit like that. Sure. Okay. Now we're going to label the angles. Let's call this one A. Maybe this one is B over here, and this one is C. Okay. Now I'm going to kind of extend the base out a little bit. Yeah. So all just parallel with the horizontal here. Yeah. And then now I'm going to draw a line that's parallel to this line that goes to this top point where C is. Okay. So parallel line there. Okay. All right. So now the reason that I'm doing that is because here from this line that's touching angle A and angle C, right? That is it's a straight line and it's intersecting two parallel lines, right? So then this angle A over here has to be the same as this angle A right here. Yeah. They have to be the same measure because it's a line intersecting two parallel lines. Okay. Same thing over here, exactly the same logic. This angle B right here is the same as this angle B right there. Okay. But now if we consider this purple angle, right, that goes from here to here, that's 180 degrees. So I have A plus C plus B is 180 degrees, right? A plus B plus C is then equal to 180 degrees. Yep. Okay, so that's it, right? Nice, easy proof of that. In case you ever wondered, and this does generalize this result, right? Yeah, I think it's if you have a polygon of degree n, then the sum of the interior angles is like n minus 2 times 180 degrees. Yeah, fair enough. Okay, but having that, right? The next fact is every triangle has at most one, and I'll say right angle or obtuse angle. Okay. Right? You can only have at most one angle that's greater than or equal to 90 degrees. Yeah. And so it kind of uses this fact right here. Let's suppose you had two angles that were greater than or equal to 90 degrees, right? You add them up and you get something that's bigger than 180 degrees, right? Yeah. So then what was the third angle going to be? It has to be a negative angle in that case, right? Or zero. Yeah. So this follows from the previous fact. Okay. Fair enough. So you can only have at most one right angle or obtuse angle in a triangle. Okay. Any triangle. Okay. And so that's why every right triangle has exactly one right angle. Okay. All right, so we have that. All right, let's do another definition here then. Okay. And again, these are things that we're probably all familiar with from high school geometry. So definition here. In a right triangle, okay, the side opposite the right angle, right, which of course will be the longest side of a triangle. The bigger the angle, right, the longer the side has to accommodate that, right? So since the 90-degree angle is the largest angle in a right triangle, that means the hypotenuse is going to be the longest side, right? So the side opposite the right angle is called the hypotenuse. Hypotenuse. Okay. The other two sides are called legs. Right? I'll usually call them legs. All right. So there we have it. Here's a nice picture for us. All right. Here's your right angle. Here's your hypotenuse, HYP. This is a leg. This is a leg. Right. Okay. Again, nothing new, right? All right. Let's prove the Pythagorean theorem. Yeah. Not so bad, actually. I say that, but then I forget that I'm actually pretty good at math. So I think this proof is pretty elementary, though. So, all right. So let's just state it first. So the Pythagorean theorem says, let A and B, let A and B be the lengths of the legs of a right triangle. And let C be the length of the hypotenuse. It's all up to how you label it, right? Of the hypotenuse. Then A squared plus B squared equals C squared. Okay. And it's only because I labeled the legs to be length A and length B, right? I labeled the hypotenuse to be length C, right? If I change the labeling, it'll say something completely different, right? So here's, let's say A, here's B, and here's C. A squared plus B squared equals C squared is what we're claiming. Okay. All right, so let's prove it. Like I said, it's not too bad. At least this proof. There's like a ton of proofs of the Pythagorean theorem, by the way. Yeah. So here's my proof. Not mine, but somebody's, I'm sure. Okay. I'm going to make a big old square, right? And the length of the sides of that square is going to be A plus B. Yeah. So let's say my A is a little bit bigger than my B. Why not? So let's say this is A and this is B. So the length of the whole side there is A plus B, right? Okay. And I'm going to make a square out of this. So then I'm going to go up top and it's got to be the same length, right? Up here, it's got to be the same length. Down here, it's got to be the same length. So this is A, this is B, this is A, this is B, right? This is A, this is B, right? So the area of the square will be the base times the height, right? So that's going to be A plus B times A plus B, right? We can FOIL this out, and we get that this is A squared plus A times B plus another A times B, so 2AB, plus B squared, if I FOIL it out, right? Any questions on that so far? Okay. Any questions on that? All right. Now, I'm going to start connecting these points. And then from here to here, and from here to here, and from here to here. And if I was a good artist, this would look like a square in the middle. It is a square in the middle. And I have to prove that it's a square in the middle. Okay. So this is a triangle. It's a right triangle because these are all 90-degree angles here, right? So each one of these triangles right here is a right triangle. Each one of them has one leg of length A, the other leg of length B, right? So then that must mean that the hypotenuse is of length C. Okay. Right? Okay. If your legs are of length A and B, then your hypotenuse has to be of length C from the way that we've labeled things according to the problem statement, right? Okay. But now, right, I have that the lengths of the sides of this shape in the middle, right, are all of length C, but it doesn't mean that it's a square yet, right? It could just be like a rhombus, basically, right? So we have to still show this is a 90-degree angle over here. That's not too bad, though, right? It's not too bad. So remember that the sum of the interior angles of a triangle is 180 degrees, right? Right. So this 90-degree angle plus, let's call this angle A, let's call this angle B. They all have to add up to be 180 degrees, right? Fair enough. So this is angle B right over here, right? This is angle A. So then if I look at this purple angle, right, these three things have to add up to be 180 degrees. Yeah. So since we already know that A plus B has to be 90 degrees, right, then that means that this also has to be a 90-degree angle here from there to there, right? So these are all 90-degree angles. Okay. So that means it's a square then, right? It has equal side lengths and 90-degree angles. So that means that the interior square here, right, is with side length C, right? All right. So I'm going to measure the area again now. I have 4 triangles, right? Each triangle, the area is 1/2 the base times the height. So 1/2 AB, right? Okay. So that takes care of this region, this region, this region, and this region, right? So I have 4 of those, right? Okay. But now I have the interior square over here, and that's just C squared for the area, right? So now I simplify all that, and that's going to be a 2AB plus C squared. Okay. That's a C right there. Let me erase that and write it a little bit neater. Plus C squared. Okay. All right, but it's the same area, right? I mean, it's just the area of the big square here. So they have to be equal to each other. A squared plus 2AB plus B squared has to be equal to 2AB plus C squared. Subtract 2AB on both sides of the equation, and I get A squared plus B squared equals C squared. Okay. Yes. Well, it's the same area, right? I'm measuring the area of the same big square, right? And this square right over here, right? I'm just measuring it in 2 different ways, is all, right? But since it's the exact same quantity, that means they both have to be equal to each other. Okay. All right. So next class, we'll actually do some examples that involve the Pythagorean theorem, okay? And talk about the trigonometric functions, okay?